Hi, this is Swapnil Bharti and welcome to another episode of TFR Insights. And today we have with us Marcio Saito, CTO of Opengear. Marcio, first of all, thanks for coming to the show.
Thank you for having me.
Before we kind of deep dive into, the COVID-19 and what challenges businesses are facing, I want to understand a bit about Opengear. Can you tell us just a bit about what does the company do?
Yes, so Opengear is a company that has been in business for about 15 years. And over the last several years, it became the leader in what's called out-of-band management. An out-of-band management is a system that enables network engineers, service providers to manage their network infrastructure even when the production network is down. So this is really what we do. Is a system that helps people to manage large network infrastructure.
And when we look at this crisis that we are all going through, we are supposed to be at a lot of physical events, but we are doing everything online virtually, which also means that actually network is the bridge, all the connection that we are making. What I want to understand from you, as you have been working with your clients, your partners, and you do see because we have never seen this kind of demand of peak suddenly where there is all the traffic is moving. So first of all, what kind of challenges this crisis is creating, especially for the network infrastructure?
If you're managing servers or storage or cloud infrastructure and the underlying network infrastructure is working, then you can work from anywhere, right? You can use your management tools. The management tools can reach all the devices and you're fine. So the network infrastructure is really the lifeline for everyone else in IT because everyone relies on the network to do their job. So having a resilient network is very important, particularly in these times of crisis where the coronavirus, what it does, it basically forces everyone to work from home. And if you're in a virtual environment and you have an internet connection, you can work from home, and that's not big deal, right? The difference is that in networking, there is this there is always the need to connect point A to point B, right? So there is always a geographical, a physical connection between the work you do in the logical layer and the physical layer. No matter how much you virtualize, how much you automate, uh, network engineers, they do need to have access and connect to physical devices at remote sites. And that's what makes network infrastructure so special. And if the network engineers cannot connect physically to a device, then they cannot do their work. And that's why sometimes it's very difficult if you're managing a network infrastructure to be able to work from home. You need to be able to connect to physical devices, even if your internet connection or even if that site becomes disconnected from the network.
Working from home is just one aspect. I mean, personally, I have been just ordering things over Instacart or Amazon Prime because I just don't want to go. So a lot of businesses which were relying on physical or other activities, banking or everything is moving online, which also means that for those businesses to offer continue to offer their services seamlessly, without any interruption. Number one. Number two is in the cloud world, we always talk about, high availability, data recovery. But the thing is that network, as you said, that is the lifeline. Without when your two data centers are not connected, there is no backup, there is no resiliency there. So, just from your perspective, because we don't talk when we talk about cloud, we talk about everything, but we don't talk much about networking, and that is a lot. So how critical is network infrastructure for this business continuity? So whether it's Amazon or and everybody's watching Netflix, so and then there are a lot of these are entertainment, but there are a lot of critical infrastructure that relies on networking as well. So what role does network infrastructure play so that these businesses can continue to offer their services without interruption?
I think most businesses that are managing a cloud infrastructure, providing service to consumers and to business, they are designing their infrastructure to accommodate changes in demand, right? So if you're in retail, you have to be dimensioned so that you can scale your services during Black Friday week, for example, right? So I think every business has seasonal variations in demand, and most people designing cloud infrastructures, they have thought about that, and they have infrastructure that can actually scale to cover the demand. What happens is one thing that is more difficult to scale compared to web servers and just compute nodes is networking, right? As I mentioned before, in networking, there is always the connection between point A and point B. So there is a physical infrastructure that needs to be built. You cannot just push a button and create a new virtual network, right? The virtual network requires a physical infrastructure underneath, and building out physical infrastructure takes time and money. So the big challenge all the service providers are facing today is that they can scale their compute nodes, but they cannot scale the networking at the same level. And when everyone is trying to access the services from home, or the demand for online shopping increases all at the same time, right? It doesn't follow the patterns of demand from the past, because everyone is rushing to the resource at the same time. So the big challenge service providers are finding today is how to scale the network fast, and we can see that in our business. Though in the last several weeks, the enterprise business has gone a little bit quieter and slow. The business on the service providers is booming when it comes to networking equipment and management tools, because they are trying to add network capacity as fast as they can.
Yeah, and as you were explaining earlier about Opengear, how Opengear tackles this problem?
As I said before, right, the network is really the lifeline for everyone else in IT. But if you are a network engineer and you're responsible for maintaining the network running, when something goes wrong and you lose the connection to the network, or a specific site goes offline, Opengear creates a system that is the lifeline for the network management people. So what we do is we create a system that is separate from your production network. It relies on LTE cellular connectivity. And basically the value proposition of our system is, I'm a network engineer. I go to Opengear and I say, I need to reach the management port of my router number 3 in the London data center. And I don't need to know what the state of the network is. I don't need to know if the internet is up or down. I don't need to know if the data center is up or down. I go to Opengear and Opengear takes me there. That's the value proposition of our system today, and that's how we help network engineers to manage a network.
I want to understand, that you explained what the company does, but I want to understand the core components of Opengear. How much of it is hardware, how much of it is software?
One principle we have, right, to scale and to make a network more resilient, particularly if you're talking about wide area networking, where you cannot create redundancy for every single component of your infrastructure, right? If you're in a data center, the traditional way to increase availability is redundancy, right? You just add more. If you're concerned about one switch failing, you put two switches in parallel. If you're working at the edge, if you're working a geographically distributed network, redundancy sometimes is very expensive and sometimes is not even viable. So what you need to do is to take a different approach, right? To follow a different strategy to be able to manage a distributed network. And to a large degree, we need to borrow from the telco industry. The telco industry has been managing distributed networks for decades. And the secret for building a resilient network infrastructure is really to separate the data plane from the control plane, as well as the management plane, right? If you have those infrastructures separate and independent, then if there is a failure in the data plane because there was a security attack or because there was a connectivity problem, your management plane is still working, and it still enables you to monitor, to manage, and to remediate problems, right? Out of band. And the concept of out of band access, out of band management came from the telco industry, where you have the phone lines that provides the voice connectivity, but the switches, they talk on a separate infrastructure using separate protocols to connect the calls and to manage and monitor the quality of the calls, right? So when networking goes to the edge, you need to take a different approach than you take in the data center by separating the management plane from the data and control planes. And that's really the strategy we follow, we recommend, and we implement to our customers.
We have talked mostly about coronavirus here, but in general, when it comes to network resilience, there are a lot of challenges. You're the best in the best position to talk about that. Can you talk about what are the some of the top challenges that company face when they try to deliver end-to-end network resiliency?
That is an example I like to give, is an IoT example. So if you think about IoT today, the questions people ask to an IoT system are things like, I want to monitor the temperature at that site. So every 5 minutes, just collect the temperature and send to me, right? So if you're doing that, you can do that from a cloud server. And basically every 5 minutes, there is a data packet coming from the edge to the cloud infrastructure. Now, what's going to happen in the future is that the questions we are going to ask our systems is going to be different, right? So imagine you have cameras deployed over all traffic lights in a city, right? And let's say you want to ask the question, a camera, I want you to tell me when a police car crosses this intersection, for example. One way of doing it is to have the video camera streaming video 24/7 to the central site, and you would have tens of thousands of cameras doing that, and that of course consumes a lot of bandwidth and it's just not practical. So what's going to happen is you're going to have to push the algorithms, right, the intelligence to detect patterns to the very edge of the network. And this is what's happening in IoT. This is what's happening with a set of other next generation applications where you need more intelligence at the edge. And the challenge you have there is you have to deploy more compute resources, right, close to the end user, farther from you, farther from the network operation center, and you have to rely on wide area networking connections, which are not as resilient as network connection within the data center, right? So you're facing the problem of less reliable connections, and you're facing the problem of having to deploy computer nodes at the edge of the network where you cannot have a lot of redundancy, right? So if you have a small data center at the top of a cellular tower, for example, you might have 20 servers there. You cannot just say, well, if a server fails, I'll just move the workload to the other one. If you have tens of thousands of servers, that's a valid proposition, but not if you have 20 servers on top of a cell tower, right? So that's really the big challenge people have when they are managing network infrastructure and the workloads are moving to the edge.
When you look at edge computing, as you also mentioned, that a lot of decisions are being made at the edge for a lot of reasons. It could be the privacy, it could be latency, it could be why are you moving all the data from here to there. So at the same time, edge is kind of also becoming a kind of data center in a way or so. So what unique kind of either opportunities or challenges edge poses for networking or for a company like Opengear?
Yeah, so when we talk about the edge, right, we are talking about the devices very close to the end user. So all the way from their mobile phones to IT equipment inside branch offices and things like that. But for the service providers, right, for the companies that are providing cloud services to the consumer, and let's take video streaming as an example. We know today that if companies like Netflix were trying to stream video all the way from a central location, they would consume all the bandwidth available on the internet, right? So what they need to do, or what Google and Microsoft and Nintendo need to do if they want to do game streaming, is they need to build these data centers that are edge data centers. They're very close to the end user. They might be a small data center, in your neighborhood. It might be a data center that's set on top of a cell tower. It might be a data center that's set inside the traditional telco central office, right? So what we're going to see in the next decade is the multiplication of those edge data centers, which require very different approaches in managing, in maintaining. Because in a data center, if something physical breaks, you just send an engineer there and they can replace the equipment. If you have servers at the top of a cell tower, they might be in very remote locations where you just cannot afford to roll a truck and send someone there, right? So the approaches you need to take they are different. It's less about redundancy, it's more about separation of planes. It's about being able to remotely connect and manage even at physical level without having the need to send someone there. And that creates a lot of challenges that the industry is coping with. We are learning how to manage edge infrastructure and creating a lot of opportunities for companies like Opengear who are creating the systems that enable that, right? So with Opengear today, you can connect network engineers to devices at the edge, so people to ports. But what we are developing and what the vision for our system is to evolve out of band management systems from being the connection between people and ports to being the system that extends the reach of automation and management systems so that they can reach the edge even if the production network is down. That's really the next step in out of band management is how do I help configuration management systems like Cisco DNA Center, for example, or log management systems like Splunk, or traditional monitoring systems like SolarWinds, right? All those tools, now they need to manage infrastructure at the edge. And if a remote site goes down, that's exactly when you need to manage that site. And the traditional approach doesn't work because suddenly, if the network is not there, your management doesn't work either. So Opengear is expanding the scope of the out-of-band management system, not only to connect people to parts, but to extend the reach of those systems to the edge of the network.
So talk a bit about the trends that you're seeing in terms of NetOps there, and how do you actually help companies in kind of embrace some of these practices or concepts.
So let's start with DevOps, which is the more generic terms, right? So DevOps is really collapsing development and operations so that you have a more continuous cycle rather than you design your infrastructure, you deploy, and then you keep it untouched for 20 years. You try to follow a more continuous approach where you're constantly designing, developing, deploying, getting feedback, and changing your design, right? So that's DevOps. It involves the application of automation. So it's less about manual operations rather than you doing something. You should spend your time writing code that you can use to automate the process, right? So this is in a nutshell, very high level what DevOps is. And the same applies. We are trying to break the silos and make management of infrastructure more uniform. So the DevOps principles also applies to NetOps, right? So NetOps, network management people, they are trying to adopt the same thing, but network is the most conservative of the silos because first they have more responsibility, right? If the network is down, everything is down. So they tend to be more conservative. So that's one of the reasons why the network infrastructure is still not automated, is still not fully virtualized. But there is another aspect that makes NetOps or the network portion of DevOps different, which is again the connection between the logical and the physical, right? You can virtualize, you can automate, but in networking there is always the physical connection, right? You're never gonna get out of managing physical devices and mapping your logical resources to physical devices. So, and that's why I use and why Opengear uses the term NetOps, because though DevOps applies to everything in IT, NetOps is still special. The network is still special because of the connection between the physical and logical layers. And the networking people they have different challenges when they try to automate, because the automation has to work over physical devices. And again, it goes back to your first question. It's very easy to scale compute nodes. It's not as easy to scale networking devices, right, on that network infrastructure. And that's why I do think DevOps is going to equalize all the other silos in IT, but networking is different, and NetOps has to be seen as a separate discipline in the long term because of the connection with the physical layer.
Marcio, thank you once again for taking your time out during the crisis that is going on and talking to me today. I really appreciate the time and effort you put in explaining the real role that network plays in keeping our lives running while we're all stuck at home. And I look forward to talking to you again. Thank you.
Thank you, Swapnil, and thank you for having me.